So I guess those of you who are interested in this, I will just look. I'll stay near the laptop because I want to be recorded. Are interested in not just because of the name of the course, but because of the contents I posted. But in case you haven't seen them, there's a web page, and it'll give you a description of the course and the point I want to make first is that there's no textbook here. Okay, this subject, distributed collaboration, is not a mainstream computer science course. In fact, that's why this is a seminar course and not a regular, not a course with a regular number. And we'll see that this is what I'm going to teach is a function of the assignments that I've created. And literally, I was working on the assignments till late last night, and in fact, just before the class today. So what we'll do is basically see how those things will be implemented, how they'll be implemented. So the bad news, in some senses, is no nice textbook that you can read. Maybe the good news is that I will create PowerPoints for everything. And those of you who've taken my courses before know that I actually record the PowerPoints, which is what I'm doing right now. And these PowerPoints will be posted on the web. And since a couple of you have taken my course, I have learned to also create videos out of these PowerPoints. And I've posted them on YouTube. And so that's what we'll do, because if you have a Mac, apparently it's an issue looking at the PowerPoint with the recordings. And how do you know it's recorded? You see a little icon here that will show you the recording. And the nice thing about the YouTube thing is that you can fast forward and rewind easily. And I like to ask questions, and that makes the class interesting. But when you're in a hurry trying to study for your exam, I have noticed some of the students complain about the question askers and say, oh, the questions went on and forever. So you can fast forward. And in fact, you don't even have to go in the PowerPoint. If you just do play on this PowerPoint video, it'll just play the recording. And if you don't do play, you just go to one of these slides and just click on this icon. You can go forward and backwards. Okay. So I'm saying all this because not many instructors do this. I recommend to every instructor to do this, but somehow they don't. But I think that'll be in lieu of the book. Okay. And for each, as you can see, these units are all very assignment driven. So for each assignment, I'll cover some theory, and I'll have slides, and maybe I might have also some written documents, like Word documents. Okay, that takes much more effort, and but I might be able to salvage something I've done in the past that will provide you with some relevant information. Okay, so before we get on to more details, let's just try to figure out the scope of this course. Okay, so if I was to just say collaboration, and you were to use your knowledge of English, what things might it bring? What things might collaboration imply that we know we won't cover in this course? Or we shouldn't. You don't know what we will cover. Nick?
Working together with other people?
Just
like how to work together?
How to work together, maybe some sociology, right? And where so that's not quite computer sciencey, perhaps. So what? Yeah.
Editing each other's code.
Legally, right?
Well, I'm saying illegally. Hopefully, that won't be covered in this class.
Well, editing each other.
Collaboration if you don't have their consent.
No, with their consent. Like pair programming.
Yeah, no, that's actually so pair programming, sitting side by side and doing pair programming. We won't cover that. Okay, that's sort of software engineering. But what would we cover in that same vein? I said sitting side by side. What's the alternative?
Not sitting side by side?
Being far away, distributed, right? And that we would have the computer involved, right? So collaboration occurs in many ways, and we're going to look at computer-supported collaboration. Okay, that's sort of the key here. And if you just say how to work together, sociology, computer-supported or not computer-supported, maybe the theory is the same. Okay, some people think it's not. And we won't cover the postal system, okay? But we will cover perhaps email. Okay, email is a little bit, it's a little boring technology compared to what we will look at because it's old. That's what I mean by boring. Okay, so and within that, we're going to look at obviously concepts. Okay, you can always collaborate using some tool that you found on the web, and there you're getting familiar with computer-supported collaboration. But we're going to try to look at the subject in a principled fashion. Okay, so when you look at things in a principled fashion, you think of many terms, and I've thrown two words there: techniques and abstractions. Okay, so by abstraction, there's a reusable hardware or software component on which you can build your application. Okay, so it applies to some domain of applications. Hopefully, as many applications as possible. The larger the domain, the more general the abstraction. And so we are used to abstractions like memory, hardware, array, class, file, database, text field. So we look at collaborative abstractions. Okay? And through abstractions, we really learn subjects in a general way. Okay, so abstractions is one way to learn. So that's general concepts. I also mentioned techniques. So what would be the difference between techniques and abstractions? Is one superset of the other? Is one subset of the other? Are there disjoint sets? Or think about it this way. Not every course teaches you abstractions, right? And yet they all teach you principles and concepts. So what are the kind of concepts that are general, that are not abstractions?
Like design patterns.
Design patterns, okay? You don't have an abstraction for observer. Okay, but you're told that if you have a program that has the observable pattern, there are two objects defined by you that have a certain protocol in which so protocols. If you take Jim's class, you'll be learning not abstractions, but he's teaching two classes, Jim Anderson, algorithms. Okay, so you learn algorithms and patterns. So basically something that's a concept that is applicable to a large set of applications, but that hasn't been codified into an abstraction. Okay? So we learn that also. User interfaces, okay? We're talking about collaboration. These are interactive applications. So we learn some user interface techniques. A lot of algorithms we look at. We look at some design patterns, and we look at architectures. That's another thing. Okay? And those of you interested in cloud computing and distributed computing, you talk of replicated, centralized, client-server, peer-to-peer. So all of these things apply to some extent in the collaboration domain. Okay. So then the next question is, what exactly is a collaborative application? Okay, so it's very clear it's a computer application. Okay, so we are going to look at techniques of supporting computer applications, and if it's pair-to-pair programming like this, it's interesting from software engineering point of view. But from a distributed collaboration point of view, it's more interesting when you do distributed pair programming. Okay? And that's something actually I've worked, that's something very close to my heart because I've worked on it in my research. So how would you define a collaborative application? How would you distinguish a collaborative application from a non-collaborative application? And there's a picture to help you, but let's just spend a few minutes on this. So a collaborative application is an application that
maybe serves as a medium for multiple devices to interact.
So it allows multiple devices to interact with each other, and the devices could be mobile computers and so forth. So how would you distinguish between distributed applications and collaborative applications? And those of you who are in here because of the distributed term, you might find, you might run away from the course because it's going to focus on a subset and not the whole set.
So collaborative application has multiple clients that work together for the same goal.
Okay, so multiple clients working on the same goal. So if you have multiple computers trying to find prime factors of numbers, would you call that a collaborative application? Some people do, actually. But you're right. So clients, you mean what? Computers or? People. Okay? There's people involved. There's a user interface involved. Okay? So allows, What if I said it's an application that interacts with multiple users? That's not quite your application, your definition. You said the users must work to, clients work towards a common goal. So if I just had a time-sharing system, okay, where you have one computer that is being used by multiple users, would you call that time-sharing system a collaborative system? Because they don't interact with each other. Okay, the whole idea of a good time-sharing system is to isolate the users, make you feel the other user doesn't exist. Okay, really, that's the goal. You know, you guys don't know what time-sharing systems, but you know, in the dark ages when we had to go and share computers, try to write a compiler, try to have 50 students trying to write a compiler at the same time, and run the compiler on a time-sharing system, and then you really realize that there are other people around. You know. But that's not supposed to happen, okay? So we are going to have, so one user's actions can influence the other user's display. We'll look at a very technical definition. Whether that's whether that's serving a common goal, who knows? Okay, maybe they're fighting with each other. You know, maybe they're competing rather than cooperating. So that's in the mind of the user. Okay, so from a technical computer science point of view, as long as my actions can influence your action, we are collaborating. We are using a collaborative application. Okay? And when there are n users, what should I say? Each user's. So let's just look at a collaborative action. So this guy makes a square, and it goes to every user. So user inputs the command draw red circle, and it's seen on other users' screens. Okay, so this seems to meet the definition of a collaborative application by example, right? So should I say that every action of a user is seen by every other user in the application? Should we make that the definition of collaborative application?
Not necessary.
Not necessary. So what's a practical example where every user's action is not seen by every other user?
Exams.
Sorry?
Exams.
That's, again, an isolation. That's not supposed to be collaborative, right? That's like a time sharing. And if it doesn't, then we have a problem.
I'm imagining like a game with multiple participants, and you need to be able to like send a message to one of the other players that all of the other players receiving that message.
Okay. And Google Docs, is that a collaborative application? Is every action seen by every other user? If I make my window larger, is your okay? And in fact, it may not be seen immediately. There might be some delay, which is okay. You know, as I'm composing my IM message, not every character is being seen by you, but when I hit return, you see it. Okay, so then we don't quite know what the definition would be, and we'll just use a so there's going to be coupling among the users. Okay, so that's a key here, that there's going to be coupling, and we'll say that a user's output can be influenced by the input of at least one other user. Okay, otherwise that users is that, so that's part of the definition. It's not quite complete, yeah.
What about a system where you have voting or something like that to come to a consensus? For example, the blockchain. You end up with a consensus, but that doesn't necessarily that represents an aggregate of
Sure. So that's what I said. Output can be influenced by the input of another user.
Okay.
I'm not saying the output is seen.
Yeah.
Every input is seen by every other user. There is some function.
Yes.
Okay. So, what if I'm presenting these slides to you on your screen? Right? So each one of you on your computer screen is seeing the slides. Is my output being changing as a function of your input? Your output is, but not mine. Okay, so you want the dual of this also. Okay, or a user's input can influence the output of at least one of them. Okay, so that means you're there. I mean, every user is there for a reason. They're either seeing action of somebody else, or they're influencing the actions of, they're influencing the views of somebody else. Okay, so we'll use a fairly loose definition, very broad definition of collaboration. Okay, in our projects we'll be looking at more synchronous applications, but the field is larger than that. Okay, and we'll be referring to concepts that have loser couplings also associated with them. Okay, questions so far? So, given that people have been collaborating with each other for, since human beings evolved, and why look at computer collaborative applications? Why provide computer-supported cooperative work? What's the motivation for this domain of applications? Why provide IM? Why provide games? Why provide email?
I think it's just a matter of a lot of experiences. Can still be shared long distances or a lot of work and still be in a long distance. You could work with someone if you had the tools to be able to work with a long distance. Without, some people just cannot work in the same place.
Okay, so that is the main motivation. That when we talk of working with each other without computers, we talk of being there at the same location. Okay? And so we're talking of face-to-face interaction. And what you try to do with computer-supported interaction is that separate the users, go from pair programming to distributed pair programming, okay, so that they can work with each other. And there are many reasons why you want to be geographically dispersed. Okay, you might just be located there. You don't have the time to go to somebody else's location. You don't have the resources to go to somebody else's location. Okay, so you're trying to create a simulation, okay, it's like virtual reality. Okay, virtual reality tries to simulate reality. This is a special case, if you will, of virtual reality. We are trying to simulate collaborative face-to-face interaction. Okay, so that's sort of the main motivation. And you've got a picture here that you probably can't interpret, but have you guys seen so there's a degree to which applications take you there to face-to-face, simulate face-to-face interaction. So what's the highest degree of simulation you've experienced or seen in applications? I mean, email, would you say that's taking you all to one location? IM? A little bit more maybe? And what's the highest degree you've seen or heard of?
Video shot.
Sorry?
Video communication.
Video communication? A little bit more, little higher than that?
Some Fuchs work.
Sorry?
Some Fuchs work. Telepresence.
Telepresence. Okay. And what's the idea here? What's the idea there? How would you define telepresence?
Basically getting the idea that the person is in the same room with you. You're not just seeing
Video
where they are, you're seeing it and as if they were in the same place.
And they also can view you from one angle, another angle. You build a model of the whole environment and you present it to them.
And
Okay.
it's within your environment.
Right. So that's Henry's vision, and his driving application was remote surgery. The idea is that a surgeon in Australia is a favorite example here because it's very sparsely populated. So the expert is very far away from the person who's not the expert, and he's helping the non-expert do the operation, and he's looking at the patient from one angle, another angle, and so forth, and guiding them. Okay? And here's something from Japan that's actually mid-90s, I think. That's in that spirit. And the idea is that you have a surrogate, a robot representing you in the other world. Okay? And so there are two users here. One is the controller, one is the viewer. And the idea here is that one person is training the other person into the use of some equipment. And both users can see, so the robot has a camera, and that whatever the camera captures is seen by the remote person. So you can move the robot around remotely to go and get a view of different aspects of the room, and you can zoom in visually. And I saw this demo in a conference, and this was invented by Japanese, and when the robot entered the room, it bowed to the group. So that was very realistic in that sense. Okay, so so we're going to look. So that's an extreme form of transportation, telepresence. And again, Henry wants, what Henry wants is large size avatars, so that you really feel that, not a small little robot, so that you really feel their presence. Okay, and a lot of people are doing research on this area. Okay, and that gets into highly graphic stuff, which we won't look at, but we will look at applications that are taking you towards being there. And when you do synchronous collaboration, essentially you're aiming for being there, okay? Because at least you're there in the same time. Now, the being there goal is an interesting goal, but it's kind of a depressing goal. Okay, and reason is that you look at the lines I've drawn here. The line here between the users is very thick. The line here between the users is very thin. And what's that saying? It's saying that computer-supported collaboration will always have less bandwidth, if you will, than face-to-face. Okay, it's always the second best thing. Okay, only when you don't have time, when you have time and cost constraints, that's when you use it. Otherwise, do face-to-face. Okay, and how can you make it less depressing? How can you? What kind of goal could you have to make the technology more interesting? So towards being there, what's the dual of that? So when the virtual reality guys did virtual reality, and they said, okay, walk through the building and see the ship, or see the building or the ship, people said, can you teleport us, please? We don't want to walk, right? So you don't want reality sometimes. Okay, you want to go beyond being there. You want to provide modes of collaboration that are not supported by face-to-face interaction. Okay? And a lot of people do work in this area, and most of my work is being done in this area. So if you talk of concurrency control of any kind, that is beyond being there. If you talk why is email so popular, we don't have to be there at the same time, same location to collaborate. We can be at different times. Okay? So, so you try to provide in computer-supported collaboration modes that are not supported in face-to-face interaction. Okay? You go beyond being there. And this idea was first suggested by a couple of guys at Bell Labs, and one of them is at Stanford right now. I'm not sure where the other guy is. So they argued that you should go beyond being there. And that's what people had been doing for a while, but they just articulated in an abstract form this twin goal of collaboration technology. Okay? So, and you should use it even when face-to-face option is available. And this seems like an abstract concept, and I used to talk about it very abstractly till I went 1 year to Microsoft and worked with folks there. And I was working with a collaborator. We went for lunch, and he dropped me back at my office, and I asked him, okay, where should we work? Or we were driving back to to Microsoft, and we said, where should we work? My office, your office, or our offices? And here we have nice big offices, so I don't mind you coming into my office. It's a pleasure. But Microsoft has small cubicles, and we decided we would both like to be in our own offices and work remotely rather than be cramped in one office. And of course, we have more flexibility. So that's what you want. You want to use collaboration technology. You want to build the kind of collaboration technology that is so compelling that you don't want face-to-face interaction. You want to use that technology. Okay? Questions? Okay. And here's an example talking about Microsoft. Here's a tool built at Microsoft. And when we talk of being there, we think of video, as somebody mentioned, as Fred mentioned. Here we are seeing recorded video. Okay, so the idea is that the lecture was presented earlier, and we are now browsing through it, and we are using beyond being there capabilities. Okay, so you can play pause. Okay, you can't play and pause me right now, but if I have a recording, you can do that, right? So that's one thing you can do. What else do you think you can? What else are beyond being there capabilities that you might want from a recording? Sorry? Captions. Okay. I'm sorry if I'm speaking fast, guys. Slow me down. Okay. I know some of you, English is not your native language, and of course I have an accent, and I tend to get, when I get excited, I try to speak very fast. So please stop me. But it will be nice to get a transcription.
You can actually slow the video down.
You can slow it down. Maybe you're thinking of me.
No,
But for other lecturers, you might want to do what? Go, make it fast.
Get it over with.
Right? You know, develop, build topics out of it, perhaps. Okay. So they did all of this stuff. Video processing. They did. You could bookmark things. Okay. You could remove pauses. Okay. You can time compress. You can do automatic table of content generation. You can develop slide summaries. And by the way, do you think this is futuristic, the stuff? Is this where education might go? You think so?
Yeah, definitely.
Do you have any examples to show?
Like all the massively online courses like Udacity, Coursera.
So is it Udacity or Audacity? It's Udacity, right?
Yes.
Yeah, I always think of the English word. So Udacity is very compelling. A Stanford professor goes and offers the course to 100 people at Stanford and 100,000 people elsewhere. So, you know, the people paying big bucks get to be in the room, and other people are taking it for free. And what happened? His classes became 5 or 4 students because they all preferred the other technology because they had these capabilities. Plus, they had automatic, you know, there were quizzes associated with pieces of the video, and you couldn't go forward till you had answered the quizzes. So, you know, so you couldn't quite sleep in the back and not understand things. Okay, so yeah, Microsoft is not doing anything with this, but the world is. Okay, so this is interesting. That gives you a scope of what happens, and often the two goals are combined. Okay, so this is video chat, or this is a graphical chat, and what's happening is, let's see what I have here. You feel transported to a virtual world, so you're not just entering text. You have avatars that represent you and in the world, and you can move your avatar next to another avatar, and if avatars are close enough, can you be heard by the other person. Okay, so it's not as if this is a large group here, and it's not as if every person is communicating with every other person. They're communicating with only people in their aura. Okay, within certain distance of them. So that's feeling that you're in a common world. And you know, you can select what your avatar is. So that's beyond being there, and so there's anonymity. So what we're going to do in this course is a mixture. Okay, we are not going to focus on totally asynchronous collaboration. Okay, we're not going to look at highly graphical stuff. Okay, but we're going to do things in the spirit of the slide I just showed you earlier. Okay, in fact, we're going to be building an IM and editing tool. So that's the kind of tool we'll be building. Okay, and the concepts from other tools also apply there. Okay, so collaboration technology is built on top of other technologies. Okay, it's built on top of programming languages. If you're going to build a collaborative application, you're going to use some programming language. You're going to have an operating system. What other kinds of technologies might be the base technologies for collaboration? And distributed computing, okay? And so distributed computing and something else?
User interface.
Interaction technology, right? So that's the thing. You're basically combining interaction with distribution, okay? So you'll be dealing with toolkits in this course, okay? Not in a detailed principled fashion, but you'll have to use them, okay? You'll be dealing with distributed technology, again, not in a detailed principled fashion, but you'll be using them. Okay, and I'll talk about how I'm going to try to make that stuff easy for you. Okay, so they're interactive, so there's user interface technology. They're distributed, so you're dealing with inter-process communication, okay, which is built on top of networking. And in both cases, when you have graphical user interfaces, you have to know about threads. Okay, or the threads exist whether you know about them or not. Okay, and again, distributed technology, you have to deal with threads. Okay. So the prerequisites I'm making for this course are, A, you have to know object-oriented programming, because this is going to be a complex program and it's going to be hard to build without knowing object-oriented programming well. You don't have to know these two technologies in a principal fashion. You can just Google and that'll be sufficient. And you have to know threads in a principal fashion. Okay? So if you've done operating systems, that's great. If those of you who've done 401 with me, you know enough to do this course. Okay? And you will learn far more about threads, and that will be a good, as somebody said, I want to get more programming experience. That's the kind of stuff you'll be. You won't be writing large pieces of code. You'll be doing very small pieces of code, but they'll be complex, and they'll be concurrent. Okay, so that's 3 basics. Okay, so collaboration software is built on top of some kind of user interface toolkit and some form of inter-process communication, RMI, sockets, and so forth. And to make your task, these technologies are not easy to use. Okay, especially when we're going to build collaborative applications. And what I'm going to do is, so you will learn, the goal here is to apply these technologies, not to learn the principles behind them, like I said. So what I've done over the summer is, and I spent most of my summer doing this stuff, actually. So I came up with the assignments, and I said, what are the pain points? What are the details? What are the boring stuff? Let me abstract that out. And what are the principles, the concepts, the algorithms? And those are the stuff that the students will do. The rest of the stuff, I'll just give them software to build the algorithms on top of. Okay, so I have a layer above above RMI. RMI is about pretty much the highest inter-process communication layer. I've got a layer on top of that to make the distribution aspect pretty much trivial. Okay, user interface, putting buttons and so forth, that's easy. It's kind of boring, but it's not hard. Okay, how to capture events so that you can distribute them to other users, that is hard. So I've done some of the capturing also, and you will be mainly distributing them. Okay, so I provided these class libraries, and so you will focus. When you look at the assignments, you'll say, "Wow, can I do them in one semester?" But there's enough scaffolding I've provided for you to make that to make the task easy, so that you will essentially be doing what rather than how. Okay, so if you've done an algorithm course, you know that you focus on the pseudocode, right? You just go and figure out the flow, and this is going to be close to pseudocode programming. I mean, you'll probably disagree with me at the end of the course, but I've tried to do that. Okay, so when the problems you'll face are with wrong coding of the algorithm, not dealing with details of sockets and details of AWT. Okay, at least that's my goal. And again, help me, tell me where things can be improved at the end of the course. Okay. And okay, so the libraries have to be written in some language. Okay, so I picked Java. Okay, so if you really hate Java and you want to do Python programming, you're free to implement the stuff in the libraries. Okay, otherwise you might as well learn Java. Okay, again, I said the prerequisite is object-oriented programming. I don't think if you know C# or Python, Java is such a big deal. Okay, and if it is, there'll be some syntactic issues, and we'll have forums. We'll have a forum which you can use to exchange problems and solutions. And again, what's going to be on top of the stuff? You're going to build one abstraction, okay? And then you're going to build applications. And the applications are not going to be the interesting thing, but the algorithms, the techniques that are in the applications are going to be the interesting thing, okay? So basically, we'll be doing these two things. And you'll see, if I get time, we'll see in the demos what this exactly means today. Okay, so you can see now that there's operating systems here, there's applications on top, and anything between the operating system and the application is called middleware. Okay, so IPC is part of the OS, but RMI is considered middleware. Okay, because it's built on top of the OS. Inter-process communication facilities, user interface toolkit. The Windows system is part of the operating system nowadays, but the toolkit, the text fields, and the sliders are middleware. And then I've got something else that is higher level than that, and then you'll build something even higher level than that. Okay, so it's middleware. So I didn't know whether to call my course a systems course or an application course, but the fact that it's near the application, I made an arbitrary decision. Okay, I'm really a systems researcher, so I think like a systems person. But it's, since I'm focusing on a domain of applications, I've classified that as the application in the application environment. Okay. So what are challenges that you might have, in building collaborative software? I mean, it doesn't seem that complicated, right? Once you've got a user interface built, you've got another user interface built for another user, maybe they're the same program, you just exchange information, right? And again, I'm going to make that task easy for you. So what's the hard stuff here? What are we going to spend, why do we need one whole semester? And maybe we don't. So what are some complex things that you think you'd like to be taught? Because why take classes? If you can read, if you can Google things and learn information, why take classes? Well, you take classes to learn principles that don't come out in a bunch of scattered facts on Google, right? So what kind of, what makes conceptually this domain, this area of collaborative applications seem difficult to you right now?
Currency itself, like that, how do you solve conflicts?
Okay.
The
So,
whole round.
yeah, we're going to have 3 assignments on that.
In an asynchronous environment.
Sorry?
In an asynchronous environment.
And everything is asynchronous to some degree. Things will take time to go from one place to the other place. Okay? And if you try to make it synchronous, then you need some kind of concurrency control and locking. So, okay, that's a design and implementation issue. What kind of consistency do we want, and how do we implement it also? Anything else? So let's ask the following question. So I said there's coupling, okay? So that means there's a UI associated with coupling. That we have to decide what actions of mine go to another user and when they go. That means there must be some UI, some algorithms, maybe some design patterns for doing coupled interaction, some architectures, okay? So that's, and that's consistency is something that coupling directly doesn't mention. So besides coupling, there's consistency. What other functions do you think a collaborative application must provide? Just because there's coupling. Because there's coupling, we have to deal with consistency, right? If there was no coupling, there's no consistency issue. Right? If there's no coupling, there's no security issue in the world. Everybody goes and, works alone and doesn't exchange information, and there's no internet security. Okay? There's no consistency problem. So maybe there's security issues, access control issues. Okay? If I'm presenting a slide, maybe you shouldn't be able to fast forward it, or maybe you should because you're my co-presenter. Okay? What other things, other functions do you think beyond that are implied by coupling? Session management. How did we decide to all be part of one session in the first place? Okay? It's not a very difficult concept, but it's an issue you have to deal with, especially at the implementation level. Okay? Did I invite you to the collaboration? Did we all join go to a certain name? Okay, there are many, many design choices here, and there's some implementation issues also. So coupling, what is the remote feedback of a user command, and when is it given? Okay, so there's the local feedback. That's what interaction technologies, what single user interfaces decide, that when I input something, what is the output I see, right? That's single user interface. Collaborative interfaces, what is the remote feedback, and when is it given? Awareness. Does that English word awareness mean something to you? That may be different from coupling?
Is awareness the system's awareness of the other systems that they're collaborating with? Like
Okay,
awareness is getting feedback, getting output when another user makes a change?
Okay, so if we are in Google Docs, I enter the word woods, okay? And you go and put a space after that. I know that you put a space after that, right? So that's coupling. Okay, because your output, it influenced my output. Now, you kind of, what might be awareness in that context?
If we are in the same room and you didn't do anything, but I know you're there.
You know, out of band information. In an IM application, When I'm typing, you don't know what I'm typing, but you know I'm typing. That's awareness, that's out-of-band information. Okay? So this is not, we are together creating some artifact, let's say. And that's coupling. And awareness of what the other guy is doing that are not reflected in the artifact itself is what we'll call awareness. Okay? Control. So there's access control and concurrency control. Can you guys distinguish between those two words? A lot of people confuse these two terms.
More of security,
So
specifically preventing people from seeing something you don't want them to see.
that's access control, right? And concurrency control, that's coupling.
Currency control is making sure that they're not both writing like the same thing at the same time.
So basically, access control says who's authorized to interact. And once we figure out that there's more than one authorized person, how do we make sure they don't step on each other's toes? Okay, so okay. And you may not want concurrency control where people are just constrained to not act concurrently. Okay, so concurrency control means concurrency is reduced. And sometimes you take a very optimistic point of view and say, let them interact and we will just fix the problem later. Okay? And most games work that way, by the way. Okay? And so that's merging. And that's going to be the most interesting thing we'll do here. So how do we merge conflicting commands entered by different users? And at least to make sure that everybody sees the same thing. Okay, it should, they may not see the right thing, but at least everybody sees the same thing. That itself is a big challenge. Okay? And when you merge, that means somebody's actions may be undone by somebody else's action. Okay? In databases, that's called aborting a transaction. And so that's related to undo redo. When we talk of undo redo in a single user application, that's just regular undo redo. When we talk of undo redo in a collaborative application, that becomes basically abort of a transaction. Okay, because I undid something for the whole world. And then the question is, when I undo something, can you redo it? Okay, or do we have separate undo redo histories? Sorry.
So it's still a transaction if you can abort my initiation of the transaction?
We will allow, in collaboration, in databases, we don't allow that to happen.
Yeah.
Databases try to provide isolation. In collaboration, we're working together. I might abort your action. You want my help. Okay? You did the action. I decide whether it should be aborted or not. You don't like collaborating. I don't either, but that's okay.
That should not be a problem because we have access control. So
Yes.
you may have the right
Excellent.
to abort someone else's transaction, but someone may not.
Yes.
So don't be concerned about that.
Yeah, as long as we have access control. And if you don't want that to happen,
It's still a transaction.
What if, like in Google Docs, you write a paragraph, then I make some changes to the paragraph, then you delete the paragraph, and I try to undo.
But that's not the transaction. Each step that
Right.
is then accepted by the app by.
Right. What I'm saying is, if you roll back certain transactions, other transactions no longer make sense. Do you have to roll them all back in sequence? Because then you run into permission issues.
Yeah,
Access control.
yeah. What you're saying is, from a technical point of view, does it make sense, or are you saying from a user's point of view, does it make sense?
No, from a technical point of view, is it a transaction if someone else can abort it? But I guess that would be like if you and I both had one vote, and I voted for Clinton, and you were like, no, we're not voting for Clinton. Although you wouldn't do that.
I like Clinton. So, anyway, we'll call it collaborative transaction. Okay, if that will make you happy. But the point is that, as Nick said, that if I can delete your text that you wrote, I should be able to undo it also. Okay, that's a more structured way of undoing your change. So from a user's point of view, it doesn't make sense to prevent me from undoing when I can delete your stuff. Okay. There are many more issues. Okay, but these are the ones we'll look at. And undo redo we'll look at very implicitly in terms as a subset of merging. Okay. And so These are the design issues. Okay, then there are implementation issues. Okay, now all of you have learned how to do object-oriented programming. You know, most of you, I'm sure, have, and you feel well versed in that area. But given a new application, how easy is it to figure out? If I tell you, please provide me with a stack implementation in Java or Python, you guys will in a second do it. If I tell you, here's an application, find the objects, that's hard. Okay, that's hard for everybody. Okay, so identifying objects is an issue, and we're going to try to figure out, and that's why design patterns are so important, because design patterns tell you, if you have this kind of scenario, hey, use this observable pattern. Okay, use the composite pattern. And then you say, okay, I've got this scenario, so I'll go and use this pattern. Okay? So we're going to look at what kind of objects are going to be used in a collaborative application. Okay, we try to look at some design patterns there. And then, you know, Nick pointed out, what do you mean, asked me, what do you mean by awareness? There's awareness in the user, okay, that I know that you exist. Then there is software that I run on my computer that has to know that there is software on other computers that it's interacting with. Okay? Otherwise, there wouldn't be any collaboration. You have to have some awareness in the software to have collaboration in the user interface. And ideally, and so we're going to look at various objects that we're going to build and say which of these objects are collaboration aware and which of them are, what's the opposite of aware? Unaware or?
Blind.
Transparent. How many of you have heard that term? It's a very funny term. If I can't see something, it's called transparent. Okay? So if the application doesn't, if the software doesn't know that there's collaboration, if it can't see it, it's called collaboration transparent or distribution transparent. So we'll just talk of awareness and unawareness. And the whole idea is that you want objects to be, as much, you want high level of collaboration awareness in the objects you implement or a low level of awareness in the objects you implement. Some will have to be aware, but you want, should all the objects be aware? That's what the whole thing about separation of concerns is that, you know, we will focus on different things in different objects. So if we can focus collaboration in a few objects and the other objects don't have to be aware, that's great. In fact, if we can build an application that is shared and entirely the application, every piece of code that the programmer wrote, that's entirely collaboration transparent, that would be good, right? It means that we didn't have to implement awareness and we don't have to change any code when the collaboration changes. Have you guys ever seen a system in which you can do that? Collaborate on applications that are totally unaware of.
If you have two people sitting in front of the same computer on a Word document, we can collaborate, and Microsoft Word is completely collaboration transparent.
Absolutely. And can we have a distributed application like that? You guys have seen this?
You can almost say a wiki, but a lot of wikis will log who's edited text.
Yeah, the wiki knows. The wiki implementer had to worry about. What about Word? Can we share Word among multiple users? Good old Word? Using Skype? Okay. So that's a shared desktop system, a shared Windows system. Okay. Now you have restricted amounts of collaboration, but you can collaborate. Okay. So there's a whole spectrum of the application being completely aware, or all objects being completely aware, some objects being aware, some being transparent. I'm talking of application objects, and having all application objects be unaware, and it just be shared. Okay, you're sharing a debugger, you're sharing Word, remote desktop technology. Okay, that is actually allows you to remotely access your desktop. How was that? How did that come about? There was a system product called NetMeeting in Microsoft that allowed multiple people to share a desktop. It was very hard to maintain, and so they said, you know, let's just forget about multiple people, and let's just allow one user at a time to do it. So they took the same code and made it remote desktop. So in fact, remote desktop came from collaboration technology. And you can think of remote desktop being a special case of collaboration technology, where sometimes you're interacting with the desktop from this computer, sometimes from this computer, but never together. Never do you have multiple streams. Okay? how is the application decomposed into concurrent threads? Okay, how are the application objects placed on different hosts? Is everything being done in one central computer, and maybe you're sending the bits, the UI events across to all of the users, or maybe is it distributed among the various computers? Okay, and sometimes it's not clear whether something is centralized or is in this location or that location, because sometimes you have replicated objects. Two objects that are both on different computers, but they're physically two different objects, but logically they're one object. Okay? So that's replication, and then sometimes objects migrate from one computer to the other. So there's a whole set of things I can teach in this course. In fact, I can take 2 or 3 courses to teach all this stuff. Okay? So I'm trying to indicate that there are difficult problems in this area. Okay? And we're going to look at some aspects of all of these things. Okay? And performance is always an issue. Okay? And so how do you overcome the fact that the network might delay things? Okay? And how can we change the UI to handle that? How can we do other things? How can we change the architectures? Okay, so that's a subject. And like I said, we can look at the subject I can teach this course in many different ways, and I have done it. But this course we're going to, and one way to do it is for me to teach you theory, and then each of you picks a project, maybe a different project, and maybe that project relates to your research, so you can get, your research doesn't suffer as a result. And I've done it many times that way, and that has its benefits. What I'm going to do here is, and that's why I spent a lot of my summer designing the course, is to give you predefined assignments. Okay? And the nice thing there is that there are certain things that each one of you will learn. And the assignments are going to be layered, so they'll form a project at the end of the course. Okay? And typically there'll be 2 weeks between assignments, and then we'll take care of the weeks that there are midterms. There'll be no final. Because you have a cumulative project, we don't have to have a cumulative final exam, so we have 2 midterms. Okay? And you can discuss solutions with each other at a high level. In fact, I really encourage you to do that. Okay? And but the code should be separate, so don't do pair programming. Okay? But do pair design, please. And of course, you can help each other with debugging, as long as you're not sort of memorizing the code. And if you're helping them debug, then you know more than them, so you're not going to memorize their code. Okay? Now, this means that how well you do is a function of your friends, right, who you collaborate with. And I've wrestled with this issue, and ultimately, and I'm allowing you to come up with algorithms together. So what I'm going to end up doing is I'm just going to give you the algorithm for every assignment. Okay, for those of you who want to think on your own, just shut off or don't look at the slides. Okay, but I will give you the algorithm, and this is pretty much what happened when I did my compiler courses. That the professor gave us the algorithms, but it was not trivial translating those algorithms into a piece of code that compiled the whole program. Okay, so that's my plan, and tell me if it gets too boring if I do that. Okay, but that's my plan. Okay. And further, there'll be Piazza to discuss, and you can, as long as you're exchanging English words, natural language words, you're fine. Okay. And because it's going to be project intensive, 60% of the grade will be your project. There'll be 2 midterms of 20% each. Okay. I expect this doesn't add up to 100%, 10% fudge factor, where I take extenuating circumstances, class participation, other factors, to bump up your grade and not bump it down. I expect all of you to pretty much get between 90 and 100% of this. Okay? And if you do that, and you do at least average on exams, you're guaranteed, if you're an undergrad, maybe a B plus or even an A minus. And if you're a grad, maybe an H minus, as long as you do average or better. Okay? If you do much below average, then you're in trouble. Okay? And this is where the H's and H minuses will be separated, the A's and the B pluses will be separated. So this is, and this is sort of where I'll see how much you understood the algorithms you implemented. Okay? So do try to understand what you're doing, and you will have to. I mean, when you translate those algorithms into, I'll be just showing you pictures, and from pictures to code is not an easy task. Okay? Questions? Project heavy, okay? So the next thing I'm going to do is just give you a demo of the projects, and